Today, lesson 26A, solving one-step inequalities, day number 1. Last lesson, we learned how to take an inequality and graph the solution for that. Today is the first day of solving inequalities, and we had to learn graphing first because typically when we're asked to solve an inequality, we're also asked to graph the solution for that. We're also going to work on writing inequalities from word phrases and verbally state which properties are being used. All right, background knowledge from yesterday. Whenever we're graphing inequalities, when we have a less than symbol or a greater than symbol, we need to use an open circle. A less than or equal to or a greater than or equal to symbol, we use a closed circle because we are including the number, whereas less than or greater than, we are not including the number. So here was a problem that we did yesterday. We are including -1, and all the numbers that are less than or equal to -1 or less than -1 are to the left, so our arrow goes to the left. And then we also did this problem right here. X is greater than 4. This time we're not including 4, so we use an open circle. All the numbers that are greater than 4 are to the right of 4, therefore the arrow goes in that direction. All right, so I'm about to put an inequality up here, and what I need you to do is to find 3 solutions for this inequality. So in other words, 3 numbers that when you substitute them in for x or plug them in for x, they will make a true statement. So write this down somewhere in your notes. X plus 3 is greater than 5. Right now, to yourself, I want you to think of 3 numbers that you could plug in for x, and it will create a true statement. And write whatever those numbers are down, either below or next to this. Somebody give me one number that you could substitute in for x and it will make a true statement. 5. That is true because if you put a 5 right here in for x, 5 plus 3 is 8 and 8 is greater than 5. So 5 will work. Another one. 100. I like that one. 100. Because 100 plus 3 is 103, and that creates a true statement because 103 is greater than 5. Yes. Jalen. 3. Because if we plug 3 in for x, we get 3 plus 3, which is 6, and that is greater than 5. So how many, and I kind of asked a similar question yesterday, how many numbers do you think you could put in for x and create a true statement? Quickly share that with your shoulder partner. How many? And here's what I like right now. Yesterday we weren't quite sure how to say that, but some of you remembered what that word was that means a lot of numbers. An infinite number of numbers. Right, there are an infinite number of numbers that will make a true statement. All right, let's extend this out. This time, we want to use the same inequality, x plus 3 is greater than 5. I want you to think of 3 numbers that are not solutions to the inequality. In other words, they would not make a true statement. Think of 3 of them, and then exchange those 3 with your shoulder partner. Go, you got about 45 seconds. I need some numbers that are not solutions. -1. So if I plug in -1 for x right there, -1 plus 3 is 2. And 2 is not greater than 5. So that's one that doesn't make a solution. Animal. -1 billion. Yeah, let's see here. -1. Yeah, I have to kind of go sideways there. That is obviously not a true statement. All right, so a lot of you have your hands up, but it's obvious that there also are an infinite number of numbers that don't make a true statement here. Okay? All right, so solving inequalities. We've done lots of work with solving equations. And one of the things that we are not allowed to do is to just find the answer in our head and write it down. Okay? We're not doing that. We need to show our steps. So when we solve inequalities, we really do the same steps that we do with equations. So with this very simple one right here, it is obvious to all of us to solve that, we would need to subtract 3 from both sides. And we end up with a solution of x equals 2. Well, when we solve x plus 3 is greater than 5, we do the same steps. The inverse operation to adding 3 is subtracting 3. So we need to subtract 3 from both sides. From there, our solution is not x equals 2, it is x is greater than 2. So typically, if you have an inequality and you're solving it, you better have an inequality in your answer as well. So on the left, the equation has a solution of x equals 2. On the right, the inequality has a solution of x is greater than 2. So the steps are identical to each other. And we use similar properties that we used when we solved equations. We have an addition property of inequalities and a subtraction property of inequalities. Whenever you add the same number to both sides, you're using that property. Whenever you subtract the same number from both sides, you are using that property. All right. Everybody try number 1. And it does say to solve and graph. Here is what we should have done for number 1. We have x minus 5 is less than negative 7. The inverse operation to subtracting 5 is adding 5. Remember that the check is making sure that that makes 0, or just making sure that those two things are opposites of each other. Either way, that is the additive inverse property. And from there, the negative 5 plus 5 cancels out. And remember, our answer is not x equals negative 2. We have a solution of x is less than negative 2. Make sure if you have an inequality symbol in your original inequality, it's in the answer as well. From there, we graph from yesterday. And x is less than negative 2 means all numbers that are less than negative 2, like negative 3, or negative 4, or negative 5, and so on. This does not include negative 2, and all those numbers are to the left. All right, everybody try number 2. Let's take a look at number 2. The inverse operation to adding 4 is subtracting 4. Let's make sure that we make 0 there, or that they are opposites of each other, and they are. That is the additive inverse property. And when we finish our solution, we end up with a solution of x is greater than or equal to 1. That means all numbers that are greater than or equal to 1, like 2, like 3, like 4, like 5, or even like 1. So that means our graph should look like this. We are including 1, and all those numbers I just mentioned are to the right, so therefore our arrow is to the right. All right, everybody do both number 3 and number 4, please. We, of course, would add 2 to both sides. That's the inverse operation to subtracting 2. We're making sure that those two things are opposites, or we're making 0. That is true. And that would give us a solution of x is greater than or equal to negative 4. All the numbers that are greater than or equal to negative 4 are numbers like negative 3, and negative 2, and negative 1, and 0, and so on. And so when we create our graph, we need to do a double check to make sure that that's right. And so all those numbers that I just mentioned are to the right of negative 4. And we are including negative 4 this time, so close circle over negative 4, arrow to the right. Number 4, we should subtract 8 from both sides. That is the inverse operation also. We are creating 0 here, or making sure that those are opposites. And from there, we get a solution of y is less than negative 3, because 5 minus 8 is negative 3. And those numbers referred to by that solution are like negative 4, negative 5, negative 6. Those are all numbers that are on the left-hand side of negative 3, and we are not including negative 3, so open circle and an arrow to the left. All right, now do 5, 6, 7, and 8 and graph, and then we'll check with our shoulder partners. Number 5, we should have added 4 to both sides. We've made opposites there, so we're good. Solution is x is greater than 20. The graph does not include 20, so open circle. All the numbers that are greater than 20 are to the right of that, like 21 and 22 and 23, and so on. Number 6, we should have subtracted 7 from both sides. We've created 0 there, or made opposites, however you want to look at that. The solution is y is less than or equal to negative 18, because negative 11 minus 7 is negative 18. That includes negative 18, So close circle over negative 18. All the numbers that are less than negative 18 are to the left, like negative 19 or negative 20 and so on. Number 7, we should have added 19 to both sides. The solution is m is greater than or equal to 59. That includes 59. All the numbers greater than 59 are to the right of 59, like 60 and 61 and so on. And in number 8, we should have subtracted 12 from both sides. The solution is x is less than 24. That does not include 24, so open circle over 24. All the numbers that are less than 24 are to the left, like 23 and 22 and 21 and so on. So to the left with our arrow. Any questions so far? Should be pretty easy. All right, back side of your notes. Yesterday, and this part is not in your notes. Usually background knowledge is not in your notes unless we haven't done it in a really long time. But I had you fill out a chart like this because we have other word phrases that represent is less than or is greater than or is less than or equal to or is greater than or equal to. And I am including some of those other word phrases in the two sentences that you see in front of you. So number 9 looks like this. The sum of x and 6 is below 15. I want you to write the inequality that would represent that sentence, and then we'll take a look at it. Don't solve it yet because I want to make sure you have the right thing. Be too difficult. Yes.
X plus 6 is less than 15.
Good. X plus 6 is less than 15. Go ahead and solve it. It does not say to graph, so you don't have to graph it, just solve it. All right, the solving part should be easy. We subtract 6 from both sides. We end up with x is less than 9. All right, now let's take a look at number 10. What will that look like in terms of an inequality? And this one, you have to be extremely careful. What do you think?
W minus 8 is less than or equal to negative 16.
Yeah, this one is here, making sure that you remember those things that we talked about in the first week of school. That doesn't say W is less than, or excuse me, 8 is less than W. It says 8 less than W. That part is W minus 8 because just the words less than mean subtraction and to flip the order in English. So you have to make sure that you have that for the first part. So this should be W minus 8 is less than or equal to negative 16. Go ahead and solve that inequality. All right, let's take a look at this. We should have added 8 to both sides, and the solution would be W is less than or equal to negative 8.